Hello everyone, my name is Charan Aditya S. I am working as an assistant professor in Department of Food Technology in Hindustan College of Engineering and Technology. So today we are going to talk about the mass transfer mechanism in bakery products. Okay, introduction. For bakery goods, baking is a key process to develop desired product characteristics including structure, texture, flavor and color. Each product has its own recipe that is supposed to yield the distinctive characteristics of the product. However, those characteristics are often the direct consequence of heat and mass transfers during baking in an oven. So understand this. The structure, flavor and color, everything depends on the direct consequence of heat and mass transfer during baking. It is clear that all bakery products require a well-designed and often unique baking condition that could produce the correct product characteristics. During baking, mass transfers, including water diffusion, evaporation, and condensation, occur. So, diffusion, evaporation, and condensation occur. Okay, mass transfer mechanism during baking. During baking, water in dough and batter is transferred through pores within the dough and batter to the surface and further to the air outside the dough and batter. You can see in the image as the mass evaporation, water and CO2 is exceeding outside. This causes a structure transformation from dough and batter to crumb and crust as well as moisture loss. The moisture loss during baking is the highest compared to those in other processing steps of sweet goods. So the moisture content in baking in bakery products are very low. Mass transfer mechanism during baking. The mass transfer mechanisms involved in the structure transformation and moisture loss include mass diffusion, evaporation, condensation, and mass convection. These mechanisms also interact with the heat transfer modes. So first one we'll be seeing about mass diffusion. Diffusion is a mass transfer phenomenon that causes the distribution of a chemical species to become more uniform in space as time passes. You can see in the image a drop of chemical is added in the water and by time it's completely dissolved. That is the mass diffusion. By Fick's law, mass diffusion is driven by the concentration difference as follows. M by, that is diffusion rate by area, equal to diffusivity into dc by dx. Diffusivity is a physical property depending on temperature, pressure and system composition. Thorvaldsons and Janstad 1999 proposed the following model to estimate the diffusivity of water vapor in dough as a function of temperature. Typically, the diffusivities of liquid water and water vapor are approximately 1.35 into 10 raised to minus 10 meter square into per second inverse. Next one we are going to see about evaporation on the surface and mass convection. During the early stages of baking, water is vaporized from the surface of dough and batter to air using latent heat of evaporation. When the mass fraction of unbound water is more than 0.43, latent heat of evaporation, that is more than 0.43 delta HO, is approximately 2.3339 mJ per kg. However, during baking, unbound water is gradually decreased. That is bound water and unbound water. There are two types of water. Bound water, which is mixed, it is mixed in through the substances, that cannot be easily separated, but unbound water can be easily separated and evaporated. When the mass fraction of unbound water W is reduced to less than 0.43, the latent heat delta H can be estimated from the following equation, that is delta H equal to L by 100 W plus delta HO. During baking, there exists a concentration gradient of water vapor between the product surface and air. Therefore, water vapor is transferred through mass convection. It can be described by M by A equal to Km into Cs minus Cb. The next one is internal evaporation and condensation. During baking, temperature in outer layers of dough and batter increases first. As a result, the partial water vapor pressure in pores in those layers increases. Due to water vapor pressure difference, water vapor moves towards the center through pores in inner layers. In the inner layers where temperature is low, the water vapor becomes condensed. So you can see in the image changes in state of matter where condensation and evaporation occurs in a cyclic way. The liquid water starts moving towards the surface, but it is much slower than the water vapor movement towards the center. Thus, the moisture content of the crumb at the center is higher than the moisture content of dough. So, moisture content is higher in the crumb than the moisture content of the dough. In the case of biscuits, where surface layers dry out quickly and therefore the evaporation front moves very fast toward the center, inner layers are heated up quickly. Condensation in the central area might not be significant. We'll be seeing impact of heat and mass transfer during baking on product. So the impact is volume expansion, crumb and crust development and baking loss, impact on crust color, glossy nature and glossy appearance and flavor development. Okay, this is an YouTube link which can be used to see how the mass transfer works in baking. Thank you.